Hi everyone. So we are going to do a problem solving involving arrays in this topic. So let's dive in. So the question is find kth maximum, very frequently asked in technical interviews. So let's say we have an array. And what is an array? So I am assuming that you guys are familiar with what an array is, but even if you're not, I can quickly demonstrate. So an array is a homogeneous collection of items. In Java, it is declared in the specific format, and in other languages as well, it is pretty similar. So if we want to have an integer array, we will say something like this. It is the type, and this is the variable name. And then we have two options. Either we can write new integer array, and an array is always static. Size of the array is always fixed. So we have fixed that an array can contain only 5 items. So what will be those 5 items? These 5 items are accessed using the index. So now I can say the whole definition is an array is a indexed based homogeneous collection of items whose size is fixed and static. It cannot be increased. So index always starts from 0. So size is 5, right? That is the length. So you can say size or length, whatever you like to call it. That is 5. And the index will be always from 0 to n minus 1. You can always call n as well. N minus 1 is 5 minus 1, that is 4. So 0 to 4, 0, 1, 2, 3, 4. These are the indices. So right now, all of them will be having default values, something like it's an integer array, right? So for default value for integer is always 0. This is how the array will be populated. There is another way of declaring an array. You can always say something like, let's call it AR2. So you can have curly braces and have the array populated as well. Any random values need not be sorted. So what this will do, again, it will see or examine how many elements are there. There are 5 elements, so it will create an array that can hold 5 elements. So the length is the same. Since the length or size or n is 5, index starts from 0. So the last index will be 4. 0 to 4, basically, it will be the contents of the array. But notice the difference. Here I've created a default array, defaulted to all the default values for integer, which is 0 in this case. Here I am creating an array which should have, at the time of creation itself, the exact values that I want. So here the array will be created with the values. So some array basics, just in case you're not aware of arrays. Here, what our question is, or what our goal is, find kth maximum. So we are given an array. Let's say this is the array that is given to us. And we also given a value k, let's say 2. So I want the second largest element in this array, or the second maximum. And the array need not be sorted. So there are various approaches of doing it. There are 3 approaches of solving this problem. The first approach is, okay, if the array is not sorted, I can sort it, right? I will sort it. And once the array is sorted, how will it look like? Let's say we sort it, and then the array will look like something like this. -1, 0, 10, 40, and 50. This is how the array will look like after it has been sorted, right? So now it is pretty easy. If I have to find, if k is equal to 2, that is like I have to find the second largest. So 40 would be the answer. How did I get to this answer? Because I'm sorting it in normal increasing sorting order from lowest to maximum. So I cannot directly find this element. I can always reach it by subtracting it from the size of the array or the length of the array. So the length of the array in this case is 5. K is equal to 2. So 5 minus 2 is 3. So this is the index I'm interested in. This is the index. At this index, I have got the answer, the second largest element. So if I have to generalize it, 5 is basically the size of the array or length of the array minus k. That gives me the required index. And then at that required index, whatever value it is, that is the answer. That is the second largest element. So that is the first approach, sorting by ourselves. Now, if you examine the complexity of it, you have to sort the whole array, right? But we are only interested in the second largest element. So technically, we should not have sorted the whole array because I'm only interested in the second largest. I'm not interested in what is the third largest, fourth largest, and so on. This gives me pretty much everything. I can get the largest, the smallest, or anything in between. But I'm only interested in k is equal to 2. So we can have certain different approaches of solving the same problem. One is the heap approach, max heap approach. So this would require some knowledge of what is a heap, what is a max heap, which in turn would require some knowledge about what is a tree, what is a binary tree, what is a complete binary tree. Those things would be required for understanding the second approach. Finally, we also have a third approach that is based basically on a innovation of quick sort. So quick sort is one sorting mechanism, and we can have quick select logic that can help us to get the answer. So in this specific demo, I want to separate all the demos. I am not going to go into approach 2 and approach 3. I'm going to first get the answer by using approach 1, that is sort by ourselves, and then we can get the answer. And in the future subsequent videos, I will be explaining max heap and quick select approach. And there we can also understand what is a tree, what is a binary tree. And there we can also understand what is quick sort whenever we are discussing about approach 3. Cool. So welcome to zboard.com, and we are going to have some demos freely available on our YouTube channel. I'll be posting this video on the YouTube channel as well. And then let's start with problem solving. And while we are solving our problems, we will be also examining the relevant data structures and the programming logic. Cool. So this was our understanding. Let's try to implement it in terms of code and get the answer. So we have a IDE. IntelliJ is the IDE I'm using, and Java is the programming language I'm using. And I have not done anything fancy. I've simply created one simple class which has one simple main method. This is the boilerplate code that Java gives to us. And inside this boilerplate code, we have to write some logic. Usually the inputs also are given to us. Let's write the inputs first of all. So let's have an array. Let's have a static array so that we can use it throughout. What is static? What is non-static? If you're not familiar with it, I can create a playlist series that basically revolves around OOPS concepts, static variables, non-static variables, instance variables, classes, objects, those things. So OOPS concepts and related things can be covered in a separate playlist. Here we are not bothered to be understanding what static is. You can imagine that we have an input being provided to us in the form of an integer array, and then we can directly work on getting the answer, how to get the kth maximum. Let's say, let's keep it in any random order, including both positive and negative values. 5 elements. Let's say this is the array given to us. And now we have to find, let's say k is 2. So that is, what is the answer? We have to find the second largest element. Okay, now imagine had this been sorted, what would be the array looking like? If this was sorted, the array would be looking like -1, 0, 5, 10, and 40. So the second largest element inside this will be 10, right? So the answer would be 10. This is what the answer we are expecting. So let's write our logic. Let's first try to sort the array. So now we can sort the array. There are several inbuilt functions provided by different programming languages. Arrays.sort, collections.sort, those methods are there. But typically in a coding round, in an interview, you are restricted to use those methods. So whatever you want to use, you have to basically write your own custom code for it. So I'm imagining that is the case. You are solving this question in a technical coding round, and there you're not allowed to use any library inbuilt function. So basically you have to sort by yourself. Now, if you have to sort it by yourself, you can use different sorting mechanisms: bubble sort, quick sort, insertion sort, merge sort, and so on. So a separate playlist can be devoted to solving or sorting numbers using those specific sorting algorithms. In this question, the simplest sorting algorithm that most of the students are able to figure it out on their own just comes intuitively to them. It might not be the best in terms of runtime complexity, but I've seen the students can intuitively understand what is happening, and I can also explain what's happening. And that is the bubble sort algorithm. Two simple for loops is what is required, and we can quickly sort it. So I'm going to use that sorting algorithm first of all to sort my array. So I'm going to call a function called mySort method that is going, I need not even pass it here because I've declared it as a global variable, right? Since it's global, I need not pass anything here inside the brackets. No parameters required. Let's have this method, create method. This is another one quick thing. Since main method is always static, any method that you call from a static context, main method is static, so the entire block becomes a static context. And from a static context, if you're calling any method, that has to be static as well. If you don't have it, right, it will complain and it will give a very meaningful message: cannot invoke a static reference from a non-static context. So if you are calling something from a static context, as in this case, that method has to be static as well. Now we need to write some logic here to sort it, and the bubble sort implementation is what I'm going to quickly write. And what happens in a bubble sort is pretty easy to understand. So let's say we have an array like this. Having indices 0 to 4, and what are the values? Let's keep the same values: -1, 0, 5. Not the sorted one, but I wanted the unsorted one. -1, 0, 5. Let's make it random. Let's keep it like this, any random set of values. So when you apply a bubble sort, basically you are running two for loops. The first for loop is going to run from int I is equal to 0 throughout the length of the array. So starting from 0, length is what? Length is 5. So I'm going to run it till 1 less than the length. I less than length, I less than 5 till 4, and increment it. This is how I do traversal basic for loops concepts. So this is the ith iterator that is going to run through. Inside this, I will focus on, first of all, this element, and I will compare this element to all other elements. This is what I'm going to do. So the j will start to the next, whatever element is present, to the next of I, right? So the j will start from I plus 1. And I'll keep doing j plus plus. What should be the condition to stop j? I can write length here, but then there might be a problem towards the end, right? Because j is always I plus 1. Imagine when I has reached this position. So j will be one more ahead of it, which is a problem. You will basically get an array index out of bounds exception, which you don't want that. You can fix it by making this I traverse not till the very end, but making the I traverse till the second last element. We see the traversal of I, and the traversal of j can be till the very end. Right, so I will be at this position and j will be at this position, and then basically you are comparing it. So you can compare 40 with 0, you can compare 40 with 1, compare 40 with 30, compare 40 with 20. At any point of time, at all the points of time, is 40 greater than 0? Yes, it is, right? So if 40 is greater than 0, basically I will swap it. So if I swap it, 40 will come here and 0 will come here, right? And then I will keep comparing 40 with -1. It is greater, right? So -1 will come here and 40 will come here. Then I will compare 40 and 30. So 30 here and 40 here, and then compare 40 and 20. So 20 here and 40 here. So what happens at the end of this one iteration? This element has bubbled to its right position. If you see in the original array, the right position of 40, since 40 was the largest element, it should have been at the end. So after the end of the iteration, whatever was the right position for the first value or the 0th index value, at the end of these whole 2 loops, it has bubbled up to the right position. And that is how a bubble sort operates. So we are going to write it down in terms of logic as well. And I think that would make it all the more clear. Pretty much the same logic. I'm going to write one for loop that is going to traverse till the second last element. So the index of the, what will be the index of the last element? This would be the index of the last element. Because I'm using less than, of course, it's going to go then, it will go till n-1. That will, n-1 is the last element. So this is traversing till n-1, but I want to traverse till the second last element. This is how I can fix it. So now this is going to traverse till the second last element, and the internal loop will run from whatever is the position of I, j will start from 1 ahead of it. So j is going to start from I plus 1. So the first time this loop runs, I will be 0, j will be 0 plus 1, that is 1. And since I is going till the second last element, j is 1 ahead of it. So at the very end, I will be at the second last element, j will be at the last element. Right, so for j, I can make it traverse till the last element. And then j plus plus. So now we are able to compare the 0th index. Initially, I will be what? I will be 0. And j will be what? J will be 1, 2, 3. You can also see what is the size. Size is 5, or length is 5. And what is the last index? Last index is 4. This is going to 0, 1, 2, 3, 4. And this is going to go from 1, 2, 3. Not 4, but last, it will go to the second last index, right? Till 3. And this will go from 1 to 3, 4. So you notice that j is always 1 ahead of I. When I is 0, j is 1. When I is 1, j is 2. When I is 2, j is 3. When I is 3, j is 4. So the very first time when I is 0, j will go from 1 to 3, 4. When I is 1, j will go from 2 to 4, 2, 3, 4. When I is 2, j will go from 3 to 4. When I is 3, j will go from 4 to 4. Last thing only. And that's it. And we won't get any index on the bounds exception. This is basically an implementation of bubble sort that we are doing. The first sorting, the most basic of sorting algorithms, might not have the best runtime complexity, but comes very intuitively. We have not like understood any fancy concepts. Just by using 2 for loops nested inside each other, we are able to sort it out. So this is like from where to where. So for the first iteration, I is equal to 0. J is going from 1 to 4, right? And I have to compare. So if ARR, I am basically comparing the 0th index value, that is 10. So ARR of I, if it happens to be greater than ARR of J. So I'm going to compare this 10 with all the other values. Initially 10 is getting compared to -1, then to 0, then to 40, then to 50. And in comparison, if I'm finding it that it is big, I'm basically swapping their positions. So 10 is greater than -1, right? So 10 will come here and -1 will come here. We will be swapping these positions and we will continue our journey. This is what is going to happen. And at the end of the iteration involving I is equal to 0, the 0th index, that is 10, would have found its right position. So by the end of this iteration of I is equal to 0 iteration, 10 would have been correctly placed. So if you notice, what is the correct place for this 10? The correct place for this 10 is the second last index, right? Second last index. So at the end of this iteration, 10 would have been reached here. Other things would not have reached. 10 would have reached it. And as we loop or complete the whole bubble sort process, at the end of every iteration, the corresponding value will find its right position. So that at the end of the entire 2 for loops, all the elements have found their right positions. And when all the elements have found their right positions, the array is sorted. So if that is the case, we are only going to swap when ARR of I is greater than ARR of J. So again, swapping logic is pretty simple. We can use a temporary variable. There is another way of doing it. Let's do it first. Let's store. We can also use swap without using a third temp variable. We can also do that. Let me quickly write this. So we are first storing ARR of I inside temp, and then that's because I need to use the value of ARR of I, which is going to be replaced with the new value. So ARR of Y is now replaced with ARR of J. Try to read it from right to left. This value is being used to fill ARR of I. So now I have lost ARR of I, but before losing it, I had saved it, right? That was the reason of using temp. Since I have saved it, why did I save it? Because I need it to put it here. ARR of J should have the saved value, the unmodified value. So now I can use it. This should work. And this is the way using a third temporary variable. There is another way of doing it, that is without using a temporary variable. It's kind of a small trick, sometimes asked in the interview. So let me demonstrate it. What I'm going to do, I'm going to use ARR of I to have the sum of both of them. This will make sense in a bit why I'm doing it. Then what I'm going to do, I'm going to think of what do I need to have in order to swap these two things, ARR of I and ARR of J. ARR of J should be containing what? ARR of I. And how can I get ARR of I? From the sum, if I subtract ARR of J, I will get it. So the sum is inside this, right? In the upper line, we have got the sum. So from the sum, if I subtract ARR of J, from the sum, if I subtract this thing, what is remaining is ARR of I. So from the sum, ARR of I is the whole sum. From the sum, I am subtracting ARR of J. So ARR of I is remaining. So this whole expression will be basically equivalent to ARR of I. So ARR of I am putting it inside ARR of J. So ARR of J has the right swapped value. After swapping, ARR of J should contain ARR of I. So now it is correct. It is having ARR of I. What about ARR of I? ARR of I post swapping should have ARR of J. Again, same thing. From the sum is still inside. This is the sum contained inside ARR of I. From the sum, I need to subtract a post swapping, a error of I should contain a error of j, right? So from the sum, if I subtract a error of I should be having the right answer. So from the sum, basically you have to subtract a error of I, but a error of I has been modified. A error of I is the value of a error of I is now basically stored in a error of j because we have achieved this line, right? This control has gone past the line. So if I want to get to a error of I, basically it is error of j that is holding the value. So from the sum, I am subtracting a error of I, which is stored in a error of j, and then a error of I will have the right value. So you can try to replicate in your mind using some concrete examples. Say error of I is 10, error of j is 20, and you're trying to swap 10 and 20. Then if you try to go through it, it will become all the more clear. The only thing is we are getting the sum first. That is the trick. And here we are not using any temporary variable. No temporary variable used, right? Temp is not used. So basically saving some little bit of things on space complexity. Anyhow, this is just the swapping logic, swapping in two ways. Once we have swapped it and once we have written out the basic logic for bubble sort, our method is sorted, right? And because we are using a global array, it is basically passed by value. So when this is sorted, throughout it is sorted. So what I can verify it by running a for loop and ensuring that this indeed is sorted. So I can run a classical for loop in this way, or I can run a for in loop. Let's try the other way. This is the array name. Each and every item inside this array is of type integer. That is why the type is integer. That is why I'm writing the type here. This is just a placeholder value. It can be anything. And let's try to sys out or print them, not on different line. Let's print them on the same line. Let's print space separated values. And let's quickly test our program. This is just sorting it out. And after sorting, our job is done. Once it is sorted, we can get the answer. So yes, this is sorted. This is what I was expecting. And this is what I have got. From this, I want the kth largest value. Let's say the kth value is 2, right? Second largest value. I think it is not liking it anyways. Let me bring it down. Okay, so I've got k is equal to 2 and then I've sorted it out because this method has been called. Post sorting, I have to simply display the result and there we have completed. Getting an answer to this question, find kth maximum using the simplest of approach. This is the first simplest approach. Later on in the playlist, you can find some other approaches. Max heap is the second approach. And a kind of quick select version, that is the third approach. Kth largest value is, so instead of generalizing it, I can say k largest value is whatever is the value so I don't have, this is sorted in increasing order, so I cannot directly say give me the second index value. I have to get the second largest. So again, same thing that we have discussed here. Basically, we have to subtract it, right? 5 minus 2 from the length or the size of the array, subtract the value of k, and you will get the corresponding index. So the length or size of the array can be got by array.length, and then you have to subtract a from it, because the largest values you get from the ending end of the array, right? From the latter part of the array towards the end, you have to start counting. After this is sorted, let me see. Okay, so the answer we are getting is not sorted, right? We should have got -1, 0, 10, 40. Okay, my bad, because this has to run till the length, right? Because j is always 1 ahead of I, so this fix was needed. And now I should have got the correct answer, right? This is perfectly sorted. I runs from 0 to second last element. J runs from 1 ahead of I to the last element. Last element is ARR of length. And then basically I have to, this was just for testing whether it is sorted or not. And then after sorting it out, I am displaying this thing. Why is it showing some error? Let me see. In Eclipse, sysout is the shortcut, but I am in IntelliJ, so sout is the shortcut. And I can say k largest value is whatever is the value of k. So in this case, I have to get ARR, pass in the index, size is ARR dot length, then you have to subtract k from it, right? Let's see. So my answer is second largest element. I am passing k is equal to 2, second largest element indeed. Start counting from this is the sorted version. So second largest element, you can see 10 is the second largest element, 40 is the first largest or the largest element. Let's try to run this program and I'm getting the value. You can have it over the next line. So for that, I can quickly use a escape sequence and this should print over the next line. Right, second largest value is 10. If I want to find the largest or first largest value, it will be 40. Right, if I want to find the third largest value, which is 5, so I can just for quickly testing it out, logic is correct and the values of we are getting the intended values using the simplest of approach, right? 5. So this is working. This was the first approach. There are other approaches to it, solving this kth largest solution, kth largest value in an unsorted array. So approach 1 is what we just did, sorting it out and printing the array's specific index, that specific index that we need to print the value at that index, right? So that is what we did. We have to subtract from the length of the array the value of k, and we will get the corresponding value if the array has been sorted first, sorting it out and then printing it out. Other approaches are also there, so that would require some knowledge of heaps data structure, tree data structure, binary tree, and so on. So I can write it down and then we can cover it in our playlist in the subsequent videos. Approach 3 is using quick select. What is quick select? Basically, quick select is a version of very similar to quick sort. So that also we can cover a separate video playlist series where we are covering all the sorting logics. Bubble sort I have covered already here. This is basically nothing but bubble sort. Other sorting algorithms such as quick sort, heap sort, merge sort, insertion sort, and so on, that we can collect. And once we know what is quick sort, an innovation or a variation of it is the quick select approach that can be used as a third approach for sorting, can be used as a third approach for finding out the kth largest. So that's it for this video. I hope you like it. For further such videos, please like this series, and you can always connect with us at this link, zboard.com. Thank you.